radians to degrees, what did we learn yesterday? What do? If I have radians into degrees, yes. You got it. Multiply by 180 degrees over pi. So here's what I'd like you to do. In example 1, convert 2 pi over 3 to degrees. Try to do this without touching your calculator. Then sketch it, and then identify what quadrant the angle is in. So here I go. 2 pi over 3, I'm going to multiply by 180 over pi. So I'm going to immediately cancel the pi's. Then I know this. 3 goes into 180 how many times? 60. 2 times 60 is 120 degrees. So to make a sketch, 120 degrees is 60 degrees away from the x-axis. This is in the second quadrant. And remember when we learned about sketching angles in degrees? I said I don't expect perfection, but I expect accuracy. Your angle should not be at the halfway mark. 120 is only 30 degrees in or 60 degrees away from the x-axis. So I will mark points off if yours looks like it's in the middle. And we should be able to eyeball about halfway. All right, try example 2 and example 3. Convert your radians to degrees, then sketch the angle. So really, we're actually not going to be doing anything new today. Yesterday, we learned how to convert from degrees to radians, radians to degrees, revolution to degrees, and revolutions to radians. Today, I'm going to take you back through 7.2, but all in radians. You shouldn't get to that point. Watch this. Watch this. If you take 7 pi over 6 times 180 over pi, watch. So I'm not being ridiculous here. You should reduce first. 6 goes in there 30 times. Do you see that? So like you're pressing things that you don't need to. So in example 2, show me thumbs up. Did you get 210 degrees? All right, can I see some more thumbs? There we go. Good. All right, so what quadrant is 210 degrees? In the third. So let's kind of, a moment here, go around the quadrants. You know, go 0 degrees, 90, 180, 270, and a full time around is 360. So 210 is how far into the third quadrant? 30 degrees. So it's not halfway. It is not halfway. But then it's third quadrant. All right, now in this third one, this is where I'm afraid we're going to struggle a little bit without that calculator, but we talked about this yesterday. 4 goes into 180 how many times? 45, okay? 4 is going to go into 180. I know that 45 will go into 90 twice. So then that means 45 will go into 180 4 times. And that's one that we're going to see so often that you'll begin to remember it. What does the negative angle tell us? It rotates clockwise. Nice. Okay, that's what the negative angle will do. And then I might be asking you to do a teeny tiny bit of arithmetic. And guess what? That is okay. That is okay to ask. And it's for your good. It's for your benefit. So 4 is going to go into 180 45 times. Nobody expects you to be able to do 3 times 45 in your head. Well, maybe you could. But if I do it off to the side, that's negative 135 degrees. So stop and think. And this is where I really think we sort of lost, through this pandemic, we've lost some of the mental exercise, the mental strengthening. So I want to try this last month of school to redevelop that for you because it'll pay off in your future. So think about this. What's 45 plus 45? 90. Well, 45 more than that is the 135, right? You got 3 sets of 45. So what this is telling me when I go to sketch this, I'm going clockwise. And let me change my color so you might be able to see it a little better. Make sure you always have an initial side, and then that's going to go smack through the middle. Whoops, that didn't look so good. And I need to sketch a little arc that's negative 135 degrees. And what quadrant is this one in? It's still in the 3rd quadrant, right? We don't change the order going clockwise. All right, we're going to do example 4, but then we're not going to do this. We're not quite ready for the evaluating those. We're going to learn those next week. But convert 3 pi over 2 to degrees, sketch the angle. It is not, this one's going to end up not being in a quadrant. And what I'm finding is we need some help with fractions. So I'm going to try to go slowly here and help you with fractions. And so I really need you to dig in and see if you can't figure that out for yourself. So here we go. 3 pi over 2 times 180 over pi. I'm going to cancel the pi's and then reduce first. 2 goes into 180 how many times? 90. What's 3 times 90? 270. So I'm going to make a sketch here. And where do you find 270? It's not in the 3rd quadrant. It's on the line, right? Okay, good. So it looks like this. So now what I want to do here is I want to pause a moment. Yeah. You would say none. Hopefully I'm not going to ask you one like that. You would, but if you were asked what quadrant is it in, you would say none. It's on the y-axis. Okay. And I hope you know on quizzes or tests, I'm never trying to trick you. Never is the intention to trick you. But I could ask, it could be in a group of them that says sketch it, what quadrant, and then one of them is quadrantal. And you could say not in a quadrant, on the x-axis, on the y-axis. And that's not tricking, but that's like knowing where it's located. But good question. All right, so here's what I want you to do before we do the next example. I want you to, if I know that that was 0 degrees, that's 0 radians. I know that 180 was pi radians. A full time around was 2 pi. And you see at 270, that was 3 pi over 2. What would be this one up here in radians? If it's 90 degrees. Yeah, Andrew? Good job. That's pi over 2. So this is going to be important for our next step. Because what I'm going to ask you, starting next week, when we're in radians, we want to start thinking in radians. How many of you are in a foreign language? Like Spanish, French? Okay. Have you had it? You have to be advanced enough. My oldest son, he did, I think, 4 years of Spanish in high school. He did 3 years in college, and he said it wasn't until college that he started thinking in Spanish. He said it was like, oftentimes you do the English, you translate, and you're like doing all this back and forth stuff. And he said then it became where he could think in Spanish. So what I want us to have a goal is we want to begin to think in radians. Initially, you'll struggle, and you'll want to put in degrees and then put it back in radians. And that's okay when you're first starting. But let's tie this to what I had initially. So this is 0 radians, pi over 2 radians. This is pi radians, 3 pi over 2 radians, and 2 pi. And I know what they are: 90 degrees, 180, 270, 360. So now let's look at example 5. It says I want to find the reference angle. So something I need to tell you is if the angle is in radians and you're asked for the reference angle, it must be in radians. If you have to go put it in degrees to go find it, then you got to put that reference angle back into radians. That's the long way to do it. Okay? So I want to try to show you, so that's an option. Okay, it is an option, but it's the expectation that my reference angles will be radians because the angle was given in radians. If the angle is given in degrees, then reference angles should be in degrees. So watch this. I want you to think a moment. And if this is pi, and you've got to think about your fractions. Okay, so I've got 5 pi over 6. Can you tell that just looking at the fraction, think about it as 5 over 6. Can you tell that that's a teeny tiny bit smaller than pi? And maybe if that doesn't make sense, let me help you here. Isn't pi 6 pi over 6? Then 5 pi over 6 is a little bit smaller than 6 pi over 6. How much smaller is it? We actually know 1/6, right? So watch this. I can actually sketch this now. Now I do have to know pi over 6 is how many degrees? 30, right? Pi over 6 is 30 degrees because you'd multiply by 180 over pi. The pi's cancel. 6 goes into 180 30 times. So a reference angle, remember, is how far away from the x-axis are we? Let me repeat that. A reference angle is how far away from the x-axis am I? Can you tell now that theta prime is 1 pi over 6 away? And I did that in radians. The other option, which is way, way, way longer, is you could, in fact, convert 5 pi over 6. That would be 150 degrees. So it's 30 degrees away. And then you'd have to multiply by pi over 180. You see all that work? I don't want to do all that work. If I can think in radians, I looked at it and could figure it out without writing hardly anything down. So you have a choice. For now, I'm okay with you working it, but it's going to take you a lot longer than the intended time. So let's I need to write two more things down up here before we do the next one. So you are supposed to know cold. You need to know pi over 6 is 30 degrees. You need to know pi over 3 is 60 degrees. And pi over 4 is 45 degrees. You should know this cold. That means you know it without thinking much about it any longer. So pi over 6 is 30 degrees. Pi over 3 is 60 degrees. Pi over 4, number 4 goes into 180 45 times. So pi over 4 is 45 degrees. All right, let's look at letter B. So I have an angle 5 pi over 4. So I'm going to put pi here, but because it's a fraction with a denominator of 4, pi has an equivalent form of 4 pi over 4, right? Isn't that pi? 4 pi over 4? So 5 pi over 4, is that smaller or larger than pi? It's larger by how much? 1/4, okay? 1/4 more. Well, in a quadrant, you understand that pi over 4 is 45 degrees, so I'm looking at going 45 degrees or pi over 4 more in. So my angle is going to look like this. It's going to go 1 pi over 4 in. So this is theta. And then my reference angle is theta prime. I'm pi over 4 away. Yes. Do you understand that pi with a denominator of 4 would be 4 pi over 4? My actual angle, though, is 5 pi over 4. That's 1 pi over 4 more into the next quadrant. So 1 pi over 4 is 45 degrees. If this is 90, 45 is exactly halfway. So yes. Yes, exactly. Yeah, Bella? So I was thinking if we didn't make any problem with those and it saves like 5 or 6 or 7 they don't do it. Let's say like 7 or 7 Okay, let's try another one and see if we can't clarify it, and then we'll circle back and see if we can't clarify it. Let's try another one. So I have theta is 5 pi over 3. Okay, so if this is pi, this is 3 pi over 3. Now, do you know how much is pi over 3? That's 60 degrees, right? So I'm actually going to have to come around. So it's not always just one time into the quadrant. It depends on how big the angle is. So you understand that 4 pi of 3, okay, 4 pi over 3 would add 60 degrees in. So 2 of them is going to go beyond into the 4th quadrant, right?
Wait.
Yes, okay, so this is tricky. And so if this is too challenging on this one, I'll show you we can convert to degrees, do it, and then pop it back into radians. That might be what some of you need, but we eventually want to try to get to radians. And if you're taking pre-calculus, you have to get eventually into thinking in radians. It's okay if initially you have to do degrees.
So,
pi over 4. So you see in letter A, pi was 6 pi over 6,
Yeah.
and 5 pi over 6 is 1 in, but pi over 6 is 30, so I only went 1 in. Okay? So let's kind of talk about this letter C again. So pi would be 3 pi over 3. If this were 4 pi over 3, I would have gone 1 pi over 3 in, but pi over 3 is 60. But because it's 5 pi over 3, I need to go twice, but that's taking me into the next quadrant. So when that happens, then I'm going to look at the other side.
Going twice, like where?
So do you understand pi is 3 pi over 3 if I have a common denominator of 3. So then from 3 to 5, that's 2 sets of pi over 3.
Okay.
I've got 2 more to go. So then I said, all right, well then maybe I can go look at the other side. Go look at the fourth quadrant. 2 pi with a denominator of 3 is 6 pi over 3. Oh, now 5 pi over 3, do you see that's 1 away? But it's 60 degrees in. So watch this. And I need to ask you, because I can tell by faces, we're like, whoa, what's going on? And that's okay. You are learning some really good higher level math. So this is theta equals 5 pi over 3, but trust me, I'm going to help you and I'm going to guide you to understanding. So keep asking these good questions. We're going to get there. So then my reference angle, how far am I away from the x-axis? I'm pi over 3 away. You remember when we talked about reference angles, they're always positive between 0 and 90. So when we're in radians, it's going to be between 0 and pi over 2. But they will always be positive. Yeah. Yeah, back up.
So when I'm writing a reference angle as like a sine and answer, do you want it to be like pi over 3 or 6, or do you want us to write the degree?
If the original angle is in radians, your reference angle, theta prime, should be in radians.
Okay.
Yeah. Yes, it would be on that side. Yes, there you go. Okay, let me show you a different way. Okay, let me show you if I'm really, really losing you, let's do this. Let's convert 2 degrees. This is not the ideal, but this will work. If I convert 2 degrees, 3 goes into 180 60 times. That's 300 degrees. 300 degrees, do you see that's 60 degrees away? Okay, if that's what's going to work in your brain, use it. Okay, use it. Then, but I can't, on a quiz or a test, I can't write 60 degrees because my angle was in radians. Then you have to then multiply by pi over 180, and it'll be pi over 3. So it's faster to learn how to think in radians. But when this is new, it's higher level, okay? We're doing higher level thinking. So now, what I'm going to do is we're going to evaluate. These would be no decimals. And you're going to see this because I got a little frustrated on that maze in the card sort that students you are never ever typing this into your calculator to evaluate. This is not the SOHCAHTOA where we were trying to get decimals. These were laying a foundation for the unit circle, doing things exactly. So here's the steps. Sketch the angle, determine the reference angle, sketch the special right triangle, label the sides, sometimes they're negative, and then you'll use your SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So, and again, if you want to put them in degrees and work that way, you can. I'm going to do this one. I'm going to try and keep it in radians, but then do you see number 2 is in degrees? I want you to cross out, we're not going to do number 3. 7, or 8 on here. Okay, we're going to cross those 3 out. Cross out number 3, 7, and 8. All right, so here we go. 3 pi over 4. I'm going to stop and think a moment, and I know pi is 4 pi over 4. The other thing I need to know is that pi over 4 is 45 degrees. So I strongly recommend you do some flashcards with pi over 6, pi over 3, pi over 4, and just start to know those. All right, so 3 pi over 4. Can you tell me in what quadrant should I find 3 pi over 4? Second quadrant. All right, I've got some of you with me. This is awesome. And that's okay if you're not there yet. I'm going to get you there. So, 3 pi over 4 is 1 pi over 4 into the second quadrant. But pi over 4 is 45 degrees, so that's halfway. So, here we go. I'm going to sketch my angle. And I'm going to sketch it halfway. Yeah. Yes, that's it exactly. All right, so this is going to create a 45 right triangle. This is 1, 1, square root 2. And I went left 1, up 1. So now this is what we did last week. So the sign of 3 pi over 4, I'm going to do so. Opposite is 1 over the square root of 2. Remember, all students take calculus. In the second quadrant, sign is positive. My answer is positive. If I've made a mistake, I'll catch it. Now, we don't like to leave radicals in the denominator, so we're going to rationalize. And I get square root 2 over 2. All right, number 2. Sketch the angle. Determine the reference angle. Draw your triangle. Label your sides. Number 2 is not from this week. That one's from last week. Yeah, I strongly recommend it, especially if you're having trouble with keeping the card plugging in 8, 9, 10 o'clock at night, and then at 6, 7 in the morning, mine should be up. Yeah, I thoroughly recommend that. All right, what quadrant do you find 300 degrees? In the fourth. How many degrees away from the x-axis is it? 60. So that's definitely more than halfway, but that's giving me the reference angle is 60. Across from 30 is 1, the hypotenuse is 2, across from the 60 is square root 3. I'm right 1, but down square root 3. From the x-axis, you understand 300? I'd have 60 more degrees to make a full rotation of 360. 60 degrees from the x-axis, halfway is 45.
Oh, okay, we're done.
Okay.
Yeah, I thought we meant like the...
No, not the 300. No, sorry. Okay, so now I'm going to do my TOA. That would be the opposite, negative square root 3 over the adjacent, which is 1. And then the last thing I do is I say all students take calculus, tangent ought to be negative there. It is. So we did it.
Do you have to use that all students take calculus?
You do not if,
But it's for.
well, what I do,
Is it just for the sign?
it just tells you, so what you could do, you could ignore making that -3, do it, and then go all students take calculus, say, oh, tangent should be negative there, and just pop the negative.
So if you don't ignore it, you don't really do that.
Exactly.
That's just a check.
Yes,
Okay.
it's just a check. It's just a check. All right, in number 4, here's what I want you to do. Okay, we're skipping number 3. How about this? Convert 7 pi over 4 into degrees. Sketch it. Figure out what that reference angle is. Make your triangle, and then do your SOHCAHTOA on it. All right, number 4. I converted 7 pi over 4. I multiplied by 180 over pi and got 315 degrees. I sketched it. That is exactly halfway in the 4th quadrant. So that's a 45-degree reference angle. So I'm going to get a 45, 45 right triangle. So the sides are 1, 1, square root 2. Then tangent is opposite over adjacent. That's -1. Here's my check. All students take calculus. Tangent ought to be negative. All right, let's try another one. Number 5, convert 11 pi over 6 into degrees. Sketch it. Find a reference angle. It's really difficult to do these without a sketch. It's very difficult to figure out without a sketch. So figure out how far away from the x-axis we are, and then you'll do SOHCAHTOA on the triangle that you've drawn. So if you want to do pi over 4, okay, this would be 5 pi over 4. That's 6 pi over 4, which we do. That's 7 pi over 4, 8 pi over 4. And we're eventually going to make that beautiful connection next week. Yes. Great job. Positive because it's representing the radius of the circle.
1, 2, square root 3. You remember when we reviewed the special right triangles, we developed why those
Oh,
were
yeah. This is 45 and this is
Yeah,
36.
yeah, yes, that's the connection. All students take calculus. Cosine would be positive, right? Cosine positive is what's positive. Yeah. All students take calculus. If they do negative, the proper third is the 1. Proper the 60. That letter is a positive letter. And the A stands for all of them. So the first one.
Oh, okay. No. All right, some good thinking going on here. So I'm going to first convert my 11 pi over 6. Did you get 330 degrees? Okay, did we get 330 degrees? Yes. Okay, that's success. 330 degrees, how far away from the x-axis is that? Isn't that 30 degrees away? So, this is 330. So across from 30 is 1, across from 60 is radical 3, and the hypotenuse is 2. I'm right and down. So then cosine is radical 3 over 2. All students take calculus. Cosine should, in fact, be positive there.
Why did you change that one to this first?
I did that in number 4 as well.
Why should it be positive if it's in the fourth quadrant?
Because cosine is adjacent.
Okay.
That's the x-axis, and the x is positive there. Yeah.
Okay. So you don't, I don't have to, if that's confusing me and I just look at if it goes down.
Yeah.
It's fine.
Yeah. Yep. All right, number 6. Tangent 5 pi over 6. So convert your, now if you're comfortable working in the radians, try it. But we do need our 30, 60, or 45, 45 right triangle, so we might as well convert 5 pi over 6 into degrees. Yeah. Yes, good job, you got it. So then pi over 6, so that's why, do you remember where I said to you, you just need to know cold, pi over 6 is 30 degrees. Otherwise, you multiply by 180 over pi, and you figure it out. Yep, and pi over 3 would be 60.
Right?
All right, did you get 150 degrees? Yes. What quadrant will we find 150 degrees? Second. How many degrees away from the x-axis is it? 30. So this is going to create a 30, 60 right triangle. I'm left, so that's a negative. I'm up, that's positive. What do you mean? So, like, this would be left, if I want a point, that would be negative square root 3 comma 1. Like that. It's left and up. Every point is an x comma y. The left right is your x, your up down is your y coordinate. I'm planting some seeds here. So, well, let me finish this first, okay? This is 1 over negative square root 3. So I'm going to rationalize that. No, this is tangent 5 pi over 6. The point would be negative square root 3 comma 1, because I'm left and up. All right, let's try one more, and actually 9 and 10 go together. 2 pi over 3, here's something else that I do. If you know that pi over 3 is 60 degrees, do you know that 2 pi over 3 is just 2 of those? So I can then begin to convert really fast. Let me say that again. If you know those 3 that I told you to know cold, if you know that pi over 3 is 60 degrees, then 2 sets of pi over 3 is just 2 of 60, so it's 120. So watch this. We're going to do both of these together. So 120 is 60 degrees away from the x-axis. And then it gets faster, faster, faster once you start to remember things. So across from 30 is 1, across from 60, square root 3, and the hypotenuse is 2. I'm left, but up. So cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. So those are my answers. And see how fast I got those?